All right, we're going to do a practical example now. Example 4. If a population P of fish in hundreds experiences an exponential growth at a rate of 10% a year, it can be modeled by the exponential function P of t is equal to 1.1 t, where t is time in years. Why is the base for this exponential function 1.1? And when I say base, I really mean right here, the number here. So we're growing at 10%. Now I'm just going to switch over to the side. Suppose we're not talking about fish. Suppose we're talking about a population. And my town is Lorette, Manitoba. A great town. Anyways, if I have a town of Lorette, Manitoba, and if I have year 0 and if I have year 1, if year 0 has a population of 4,000 and year 1 has a population of 4,000, we would say that this grows by 0%. But maybe another question I could ask is, what percentage is my population in year 1 of year 0? Well, really, although our population remains unchanged, I hope that you're able to see, well, the population is just all of the population stays. So we would say it is 100% of its previous amount. All right, now let me take a look under the scenario. So this was under the scenario of 0% growth. Now I'm going to take a look. I'm going to say, what if Lorette grew at 5%? Well, if Lorette grew at 5%, well, who cares what the number is? Well, it would be, so we're growing by 5%. So it would be, pardon me, 100% of the previous year, right? You'd keep all your population plus an additional 5%. So it would really be 105% of the previous population amount. And if we convert that into a decimal, that would be 1.05, as we express that as a decimal. So really, there's growth. And I'm just going to ask, what's the opposite of growth? Now, it has many names. It has decline, but probably the most common one would be decay. Now, let us suppose that Lorette experiences a 4% decline in population. Well, who cares about the number? But I guess we would have 100% of the previous population, except for we lost 4%. In other words, we would say would be decline of 4%. However, we would say that it is 96% of the previous year's total. And if we move that into a decimal, it'd be 0.96. 0.96. All right, that was a lot of talk just to address a question. Let's get back to this over here. In a population P of fish in hundreds, experiences an exponential growth at a rate of 10% per year. It can be modeled by the exponential function P of t is equal to 1.1 t, where t is time in years. Why is the base function that it models 1.1? Well, really, we keep 100% of the previous year, and then the next year we add another 10%. So it's really 110% of the previous year. Now we're just going to graph this function, Now, it's okay. I'm going to make a pie chart or a t chart here, p and t. So if time is equal to 0, 1, 2. Now, I don't know in the context of the equation if it makes sense if p is less than 0. That's not what we're saying here. So anyways, my population at time 0 was 1. After 1 year, it's 1.1. After 2 years, it's 1.2. Let me get fancy on here. After 3 years, it is, I believe... Nope, that would be incorrect. I'm sorry. There. That's what we have. Regardless, what really matters is that we have a very slow growth here. P, and time 0 it's 1. After time 1 it's 1.1. After time 2 it's 1.12. So this will be an exponential function that is going to go very, very slowly up. But don't worry, it's still an exponential function. Exponents are really powerful. So if the same population of fish decreased by 5% a year, what would be the base? Well, it would be 100% of the total, right? If year 0, if we move to year 1, it would be 100%. But with a decrease of 5%. So this is really, this 5% really, or the second term of this binomial is really the decrease or increase. So it's minus 5%. So the base of that exponential function would be 0.95 because of our base is 95%. Now, graph the function. Well, this is going to be an interesting one, right? So if I have p and I have t, 0, 1, 2. Now, I don't have a calculator with me. I should have thought ahead of time. But thankfully, my population would be 1 at time is equal to 0. At time is equal to 1, my population would be 0.95. If you give me a second, I will quickly calculate this on my calculator. At time is equal to 2, it's 0.9025. So what we can see as t increases, p is going to go towards 0. Now, it's really hard to pick this up on the graph, but I think it's really important to sort of get the sense that my graph may look like this. And it's going to be a slow decay all the way to an asymptotic behavior where my p is going to be equal to 0. So we have the t-axis, p-axis, but the equation of my asymptote would be p is equal to 0. I hope you'll enjoy exponential functions. If you have any questions,